Okay, so today we want to go over what if you're solving quadratics and they just say solve. And you get to choose which method you're going to use. Are you going to use algebra and square root property, factoring with the zero property, completing the square, quadratic formula? Like which method should you use? So I'm going to go over how you kind of decide which method would be the better method, right? Now you can always use the quadratic formula. So the quadratic formula can always be used. But just because you can always use something doesn't mean that we always want to use it, right? So while the quadratic formula can always be used, it really takes a lot longer. If you know all your methods really well, that's the one I do last. So I never use the quadratic formula unless I really have to, because that actually takes a lot more time. I know you guys probably wouldn't think so, but if you really know your stuff, you should make good choices. So basically, I put them in order of the order I would look at the problems. So I would do, if I can use algebra and square root property, I would try to do that first because that's probably the fastest. Then the next fastest to me would be factoring with the zero property and also then completing square. So I would kind of look at them in that order. So let's look at algebra and square root property. So for algebra and square root property, you can only use that method if there's no linear term or if it's in vertex form. So you can only use that method if there's no linear term or if it's in vertex form. That's the only time you can use algebra and square root property. So notice over here we have a quadratic term. We have the quadratic term is the ax squared. The bx is the linear term, and the plain old number is the constant term. So notice in this example that I just provided right here, notice how there is no bx term. So this one has no linear term. So this would be a great problem to do using the algebra and square root property method. When it's in vertex form and it has this kind of a flavor to it, this algebra and square root property is a great method to use. So that's when you can use algebra and square root. So if it does have a linear term, you would not be able to use the algebra and square root property if it did have a linear term. So you couldn't use it even if you wanted to. Okay, so let's look at factoring. Obviously, factoring is my next favorite. Obviously, you'd have to have good factoring skills. So when would I use it? When it's a factoring problem that's easy to do, something that's not super difficult to factor. But obviously, we're assuming you guys have really good factoring skills. And then completing the square is a really good one too under certain conditions. So remember, to complete the square, the coefficient of the quadratic term has to be 1. So remember, to complete the square, the coefficient of the x squared would have to be 1. So if I have to divide by something and I get into a bunch of fractions, I'm not going to use completing the square because I really don't want to work with a bunch of fractions. And when the linear term is even, that makes me it easier because I don't have to work with fractions. That doesn't mean I can't work with fractions. And if it's not too bad of a fraction problem, I might do it. But those are kind of some of the things I look for to decide if I'm going to use completing the square. And then quadratic formula is, I couldn't do algebra and square root property. It wasn't really factorable. Completing the square was not the best issue. Oh, okay, I'll use quadratic formula. So quadratic formula is my last one that I decide on. So let's look at these examples that I gave you. So in problem number 1, I just kind of go through the list. And I say in problem number 1, could I use algebra and square root property? It has a linear term, so I couldn't even use that method even if I wanted to, right? The second method is factoring. I notice it is a binomial, and it's not a difference of square type binomial. It's just a regular binomial, and those are easy. What do they both have in common? They both have a 2 and an x in common, so I can easily factor that and then use the zero property, right? Where I set 2x equal to 0, and then 3x minus 4 equal to 0. And so x equals 0 and x equals 4/3. So see, look at how quick that was. If I use the quadratic formula, I would have to go, well, let's see, my a is 6, and my b is -8, and my c is 0. And I'd have to say -8 plus and minus b squared minus 4 times a times c. So 6 times 0, and then all over 2 times 6, and blah, 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 blah. That's so much longer. Do you have your factoring skills and it's factorable so much faster? Right? You starting to get the point? So let's look at number 2 now. So on number 2, so again, it has a linear term, so I cannot use algebra and square root property. So then I might say, well, I wonder if it's factorable. And at least it's a happy trinomial, the coefficient's 1, so it's got to be x times x. And since the coefficient is 1, I could build a diamond and say what times what is negative 48. That adds up to 20. And I can say, well, negative 1 times 48, negative 2 times 24. Nope, that's not going to work. Negative 6 times 8, negative 3 times 16. And it doesn't look like any of those are going to work. So it doesn't appear to be factorable. Maybe there's one I've missed, but it doesn't appear to be factorable. So it doesn't appear to be factorable, so move on. Completing the square. Would that be a good choice? Well, the coefficient's 1, and to complete the square, the coefficient needs to be 1. So that's a good start. And I notice that the linear term is a nice even number, right? So the linear term is a nice even number. So it looks like completing a square would be better. Imagine doing the quadratic formula, right? That'd be negative 20 plus or minus the square root of 20 squared minus 4 times a times. Look at how huge that discriminant's going to be, ginormous, right? Wouldn't that be, again, we're assuming you're not using a calculator. And so who would want to do this ginormous discriminant and then simplify that radical? That's just outrageous. So do you see how silly it is to use the quadratic formula when the coefficients and the a, b's, and c's are really big? So especially when I see a, b, and c getting to be really big numbers, I go, ugh, I definitely don't want to use the quadratic formula if my a, b's, and c's are really big. So again, it's not factorable. So I couldn't factor it. It's not factorable. So it's completing the square is a good choice. And again, why is it a good choice? Because the quadratic term has a coefficient of 1, and this is a nice even, right? So I'm going to move the old c out of the way and make room for a new c, right? I'm going to use my formula c, 20 divided by 2 squared. So that's going to give me 10 squared, right? So that would be 100 because x plus, right? If you cut 20 in half, you get 10, and then 10 times 10, so that gives me my new c is 100, right? That comes out to be 100. So don't forget you have to balance your equation, and then that gives me x plus 10 squared. That was the whole purpose, was to make that a perfect square trinomial. And then 148, take the square root of both sides. X plus 10 equals plus and minus, and then 148. Well, I know that 4 will go into 48, so 4 times something definitely goes into 148, and that's your divisibility rule. So again, if 4 will go into the last 2 digits, then I know 4 will go into 148. So let's see, 148, that's 3. That's 37 times. And 37 I know is a prime number, right? Prime numbers, the only factors are 1 in itself. So 19 is prime, 1 times 19, 17, because 1 times 17, 11, 1 times 11. And I happen to know that 37 is prime. Nothing times nothing is 37. So I don't need to waste my time breaking that up. So knowing some of your prime numbers can be very valuable. So this has to be 2 square root 37. And then subtract 10 from both sides. And that gives you x equals negative 10 plus or minus 2 square root 37. Bam, done. Right? I'll lay you odds, if you know completing a square and quadratic formula and there was a race, the person who did this problem using completing a square would beat the person with quadratic formula, hands down. Okay, so again, it's so much easier. Let's assume nobody's using a calculator. Okay, so I think we're on number 3. So number 3, once again, it has a linear term, so you can't use algebra and square root property. I wonder if it's factorable. Well, there's no GCF. Don't forget to look for a greatest common factor, and I don't see one. And if it was factorable, it'd have to be this. And then the last one is 2. So 1 times 2. And let's see, what was that sign? I can't see what that sign is because I wrote plus. So don't these both have to be negative to give me a positive and end up with some negatives there? So that's going to be negative 4x minus 1x is not going to give me that negative 7x for my OI. So so that's not factorable. So we can't, it's not factorable. What about completing the square? That would be my next choice. Well, remember, to complete the square, the coefficient of the quadratic term has to be 1. So that would mean, and that's okay, like, we can divide by 2, but if I divide by 2, look at all those fractions I'm getting into. I'm getting into 7/2 x plus 1 equals 0. I'd have to do that. I'd put negative 7/2 divided by 2 squared to get my new c. Ugh, too many fractions, right? Too many fractions. So good old quadratic formulas, where am I going to go with this one? So quadratic formula, don't I want to identify my a, b, and c? So a is 2, b is negative 7, and c is 2. So negative 7 plus or minus negative 7 squared minus 4 times a times c, all divided by 2a. So negative 7 is positive 7, and 2 times 2 is 4. And what's the discriminant? So I went ahead and paused the tape and did the discriminant for us to save a little bit of time, because you should already know how to find the discriminant. So I did negative 7 squared, which was 49, and 4 times 2 is 8, times 2 is 16, and 49 subtract 16 is 33. And 33 happens to be a prime number, right? So 33 is only 3 times 11, and there are no perfect squares hiding in there, so we are done, right? Okay, what about number 4? Which method would we choose and why? Okay, so in this problem, we are now on number 4. Which method would I choose? So I always start at so I would memorize this list and practice putting them in that order, because that's the choices. So notice how this has that little vertex, right? How it has the little flavor of that vertex kind of flavor. So since it has that, we're going to actually use algebra and square root property. Right, so we're going to move the 6 over to the other side. That gives me negative 3, x minus 2 squared, and that gives me a negative 6. Got to divide out that negative 3, and that gives me x minus 2 squared equals positive 2. Right, take the square root, and because you are undoing a variable squared by square rooting, you must have that plus and minus, and square root of 2 is just square root 2. Add 2 to both sides, and you get 2 plus or minus square root 2. Done. Right, so really knowing the different methods and why you would choose those methods is very helpful. Okay, so now we're on problem number 5. Notice on problem number 5 how we have no linear term. We have a quadratic term and we have a constant term, but we don't have, like here, right, we have the plain old x. Remember, that's your linear term. And if you have a linear term, you cannot use algebra, but here we have no linear term. So then we're going to use algebra and square root property. Right, we're going to add 10 to both sides. Remember, some of you were taking the square root. You got to divide out that 7 first. Right, you must divide out that 7 first. So that gives you x squared equals 10 sevenths. Then we undo the squaring by taking the square root, and that gives me x equals plus and minus. And then remember, this means the square root of 10 over the square root of 7. There are no pairs hiding in 10 or perfect squares hiding in 10. So we're going to multiply by the square root of 7 over the square root of 7. And that gives me the square root of 70 over 7. Are there any pairs hiding in 70? Nope, because 10 and 7, 10 would be a 2 and a 5 and a 7. So nope, there are no pairs hiding underneath there. So voila, we are done. Number 6. Well, once again, there's no linear term. So if there's no linear term, we could use algebra and square root property. But I also noticed, wait a minute, isn't this just a difference of squares? And if this is a difference of squares, doesn't this factor into x plus 5 or 2x plus 5 and 2x minus 5? So while this has no linear term, and I could use the algebra and square root property, I'm also recognizing that this is a difference of squares. So boom, I've got my two factors very quickly, and I set them equal to 0. And this is going to give me x equals -5/2 and x equals +5/2. So the two answers are plus and minus 5/2, right? Done. Now, you could have used the algebra and square root property, and that would have been a good choice too. I think they're both great choices. But don't forget to notice your difference of squares, because if you know it's a different squares, that's pretty easy as well. So 4x squared, add 25 to both sides, because I'm just showing you could have used algebra and square root property. Then you'd have to divide both sides by 4. I just think that one was, the difference of squares, I think, was really a lot easier. If you recognize it as a difference of squares, as far as, right, then you got to take the square root of both sides. You got to remember the plus and minus, and then the square root of 25 over the square root of 4, right? And that gives you 5/2. So you'll get there and you get the same answer, but I really think this one was probably a lot faster since it was a perfect difference of squares. So again, if you know, assuming you know all your strategies really well, that probably would have been a better choice in there. But either choice on your homework would have been okay. Today's about understanding why we might choose a particular method over another method. All right, so now the last one. And so the last one, once again, I go from the top. Algebra, square root property, factoring, completing the square, quadratic form. Quadratic form is my last choice, right? So I kind of go through the list. So again, because we have a linear term, I could not use algebra and square root property. So now as it factored, I go, oh my God, I want to factor that. But what if I completed the square? If I completed the square, wouldn't I have to divide everything by 16? And isn't that going to get into some really ugly fractions? And then if I use the quadratic formula, that's going to be the discriminant, and the a, b, and c are really large numbers. So again, the second option was factoring. And did you notice that these two are perfect square numbers? So is it possible that this is a perfect square trinomial? Because it looks like it just might be. So let's factor it and see if it is a perfect square trinomial. So it's suspiciously a perfect square trinomial, which means this would be 4x and 4x and +3 and +3. Is that really FOIL to give me this back again? So let's check our OI. Our outside is 12x and our inside is 12x. And doesn't that give me a middle term of 24x? So sure enough, it was a perfect square trinomial. I've got my really good factoring skills and I was able to spot it. And look at how much faster that would have been. So my answer is just going to be set that equal to 0. So my answer is going to be -3/4, right? Because you don't need to set both of them equal to 0. That's kind of silly because you're going to get the same answer twice. So why set them both equal to 0? That just seems silly, right? So you're only going to have one answer. Okay, and then just a little quick reminder. So the point of today's lesson is if you had a choice and you could do it any way, what choice would you use and why? And again, quadratic formula, hands down, last choice on my list. Last choice on my list. And then just while we have a few seconds, just talk about graphing. What if I said solve by graphing? So what if I gave you a graph and I said, what are the solutions, right? Solve that. What are the solutions? Remember, the solutions are the x-intercepts. So if this was 2 and this was 5, then the solutions would be 2 and 5. What if I had a graph where there were no x-intercepts? Then the solution would be no real solutions. They would have solutions. They would just be imaginary. So there wouldn't be any real solutions. So just a reminder on solving by graphing. Okay, word problems are up next. So here's the order again, in case you forgot it. Algebra and square root property first, and then factoring if it's an easy factoring problem. Completing the square, the coefficient has to be 1x squared. So we'd have to divide that out, and if we had the linear term was an even term, that means we wouldn't get into a bunch of fractions. And the quadratic formula is my last choice.